All right, today we are moving on to the last section in Chapter 8, which is 8.6. We're going to be comparing linear, exponential, and quadratic functions. So we have looked at all three types of these functions, and so now we're going to look at how do I know which one is going to be. Okay, so average rate of change. We know for slope of a line, if it is an actual line, it's just finding how far it's going up and how far it's going over. However, for rate of change, average rate of change, we know an exponential, the rate of change is not going to be the same every time. Think of our graph. It's going up a little bit, and then it starts shooting up. Okay, but we can still find what the rate of change is between this point and this point, or we could find the rate of change between this point and this point. So it may not have the same rate of change or the same slope throughout the whole thing, but we can find the rate of change or the slope for just a small section of it. And same thing for quadratic functions. We know it's going to be this shape here. I know the slope here to here is not going to be the same as the slope from here to here, but that's okay. I can still find the slope between 2 points. All right, so quick review of our graphs. Linear functions, remember a straight line. Exponential functions are that curved line, and quadratics are our U-shaped. So just a quick review. If the graph's given to you, it should be pretty easy to tell which one it is. If the equation's given to you, remember linear can be written in the format y equals mx plus b. Our exponential were a times b to some power. And then our quadratic functions, remember, was ax squared plus bx plus c. We've learned two other forms. We've learned factored form, which is our vertex form. We've also, factored form, which is also our intercept form. And then we also learned our vertex form. So it can be in a different format. We've also learned linear functions. Remember, we could put it in standard form where ax squared plus bx plus c. So we've learned different formats, but recognizing what each of those equations look like. All right, so the differences and ratios of functions. So it says you can use patterns between consecutive data pairs to determine which type of function model it is. In other words, if you're finding the pattern, that's called the first difference. So how much am I going up or down by? That's called the first difference. The second difference is going to be when you're finding the pattern between that pattern. So you're finding a pattern between what you already added or subtracted. So we'll look at that in just a second. So linear functions, the pattern is addition or subtraction. In other words, you subtract the numbers, you get the same thing each time. Exponential functions, it has a common ratio. So remember, this was addition or subtraction. This was our multiplication or a division pattern. Quadratic functions, we've never looked at the pattern, but it's going to be the second differences. In other words, you're going to subtract the numbers and then find a pattern within that subtraction. Okay. So comparing functions using average rates of change. So over the same interval, the average rate of change of a function increases quadratically is eventually going to be the one that increases the fastest over linear. Okay, so quadratic functions eventually over time are going to be going up and up and up much faster than linear. However, if we're talking about the average rate of change of an exponential function is actually going to be the one that's over time is going to be increasing the most compared to linear or quadratic. So over time, it's the one that's going to go up the fastest if you give it enough time. Okay. So in exercises 1 through 4, it says plot the points and then tell whether the points appear to represent linear, exponential, or quadratic. So if I give it to you as coordinate points, one way to determine what it is to graph those points. So if I draw in my coordinate grid and I graph -3, 2, -2, 4, -4, 4, -1, 1, 2, 3, 4, 5, 6, 7, 8, and -5, 8. Oops, sorry, that was 1 over. Let me delete that one. You can see very quickly that this is a U shape, therefore it is quadratic. Go ahead and plot number 2 and number 4. Let's do 2 and 4. All right, so when I plot number 2, I get -3, 1, -2, 2, -1, 4, 0, 8, and 2 is all the way up at 14. All right, we've got our graph that's going up quickly. That is going to be exponential. And let's do number 4. So plot those, pause it, and then check and see how you did once you've got it. All right, so I have the point 2, 1, 2, 3, negative 4, 0, negative 2, negative 4, 2, 3, 4 is up at 2, because I didn't go up high enough, and negative 6 is all the way up at 4. All right, when we connect it, we can see it is linear. Good. So from the graph, it should be pretty easy to tell. So let's take a look at the tables, though. All right, so first of all, when you're trying to find out if it's linear, exponential, or quadratic, check your x. So you can see on both of them, this is going negative 2, negative 1, 0, 1, 2. The pattern's consistent. If the pattern on the x's isn't consistent, you need to be really careful when you're looking for the pattern on the y's. All right, so to go from 7 to 4, I'm subtracting 3. From 4 to 1, I'm subtracting 3. From 1 to negative 2, I'm subtracting 3. From negative 2 to negative 5, I'm subtracting 3. So if that pattern is addition or subtraction, we know it is going to be linear. Okay, so on number 6, to go from 6 down to 2, I'm subtracting my 4. From 2 to 0, I'm subtracting 2. From 0 to 2, I'm going up by 2. And from 2 to 6, I'm going up by 4. So it doesn't have a consistent addition pattern. So we can see if it has a multiplication pattern. Well, 6 divided by 3, or 6 times 1/3, would give me 2, but 2 times 1/3 doesn't give me 0. So it doesn't have a multiplication pattern. But let's see if we can find a pattern here. So the difference between a negative 4 and a negative 2 is a 2. The difference between a 2 and a 4 is also a 2. If I notice right here is my vertex, there's a consistent pattern going this way and a consistent pattern going that way. It's going up by the same here. It's going up by the same here. So that one is going to be quadratic. All right. Almost done with chapter 8. So in 7 and 8, it says, tell whether the data represent linear or exponential or quadratic functions, and then it actually wants you to write the function. So that means write the equation. All right, so if we take a look to go from negative 2 to negative 1, 0, 1, 2, there's a pattern of my x's. From negative 4 to negative 1 to 2 to 5 to 8, I'm adding 3 each time. Addition is always going to be linear. So if I think about my equation, y equals mx plus b, I know that my m is going to be 3. B is my y-intercept. Y-intercept is when x is 0, so my y-intercept is at 2. So there's my equation. See if you can find the pattern on number 8. All right, so if I look at number 8, I can see that if this is my vertex, notice it's going to 0 and then to negative 9, and it's going from 0 to negative 9. So there's that consistent pattern. So I know this one's going to be quadratic because it's symmetrical around that vertex. If it's going to be quadratic, there's a couple of things that I need. So first of all, I need the vertex. The vertex is at 0, 3. If I know the vertex, then I can put it in vertex form. So vertex form was y is equal to a, and in parentheses, x minus 0, which in this case I don't have to write, but I can, squared, and then plus my k, which was my y-intercept. Okay? The only thing I still need is a. To be able to find a, all I need to do is plug in a point. So any point besides my vertex, so I'll just choose this point here for my x and my y. So that means y is 0. I'm looking for a. X is 1. And let's solve it for a. So I have 1a plus 3 is equal to 0. When I subtract the 3 over, I get negative 3 is equal to a. So my final equation would be y is equal to negative 3 times my x squared plus 3. So to find that a term, all I did was plug in one point. It doesn't matter which point. Plug in one point for x and y so that you can solve it for a, because we already had our vertex, so we could plug in the number here and here. All right. Let's go ahead and stop there for today. That's long enough for your notes, I think. So go ahead and write your summary. How do you know whether it's going to be linear, quadratic, or exponential?